In the heat transfer week, we made molten chocolate cake in lab. And we did this because we wanted to study how heat transfers into a cake or into cake batter as the cake cooks. And you can see this very well in molten chocolate cake because the crust forms, so you can measure the crust and you can see how it becomes thicker and thicker over time. So you all did this. And we hypothesized that the diffusion coefficient of heat transfer in cake batter would be very similar to water. And that of water is 1.4 times 10 to the negative 3 centimeters squared per second. And then we said, okay, so this is what we're hypothesizing, and now we will see what we all find. So here I will show you the result of what we all found in our kitchens. Okay, here we go. So here is a histogram of the heat diffusion coefficient in cake batter that you all entered on this spreadsheet. And as usual, we have the heat diffusion coefficient on the x-axis in centimeters squared per second. And it's a little hard to see, but the maximum value is 5 times 10 to the negative third, so that's a 3. And on the y-axis are the number of responses. So this is how many people got a value for the diffusion coefficient within a certain range here. So here is what we called out as the expected heat diffusion coefficient. This is the heat diffusion coefficient in water, 1.4 times 10 to the negative 3 centimeters squared per second. And as you can see, first of all, is that we have a little bit of a spread, which of course could be due to all kinds of reasons. As many of you noted, just as was the case in measuring diffusion of molecules in egg white, it wasn't always very clear exactly how to measure the diffusion of heat into the cake. And sometimes that line was kind of blurry. It's interesting, though, that many of you have heat diffusion coefficients that are quite a bit lower, about 10 times lower or so than that of water. And it's interesting to think about why this is, and I invite all of you to discuss this in the discussion forum. But one reason, of course, is that, of course, cake batter is not all water. It's also flour and eggs. And so it's not impossible that this affects the coefficient somewhat. Another reason is that we used the equation L equals the square root of 4 dt when we calculated these diffusion constants. And as we mentioned and learned in lecture 2 of the heat transfer week, is that this is a very good equation to use as a simple rule of thumb when you want to calculate how long to cook a turkey or a lasagna, but it is a simplification. And what probably describes the heat diffusion much more accurately is the heat diffusion equation. And we mentioned in that lecture that we didn't go into this too much because the mathematics are a little bit beyond the level of this class. So it's probably fair to say that if we had used the proper, more complicated diffusion equation to calculate our value of D, we would probably get a value that is a little bit different from what we get in this histogram. Nevertheless, this is what we got as a class, and there are about 700 people who entered their responses for this experiment, and this is what we found.